Hello everyone, it is Wednesday, August the 8th, 2018. The time is now 0935 hours. In this video I'm going to show you how I wire my 18 8-volt T875 170 amp hour Trojan batteries. Okay, so we begin. Now each battery, as I said before, is 8 volts. So you have 18 of these 8-volt batteries. I start with 3 batteries. So this is 8 volt, this is the 8 volt, and this is the 8 volt, as long as all the others. So we just need 3 to start the ball rolling. Now I came from the positive of the first battery and I went ahead and connected to the negative of the second battery. I then came from the positive of the second battery and I connected to the negative of the third battery. Now what I did, this is called series wiring, where I came from positive to negative, positive to negative. What happened here is that I increase the voltage of the battery, so it's 1, 2, 3 8 volts. So by going and wiring in series, I made these 3 batteries a 24 volt battery bank. Now, 2 things here. While I went in series and increased the voltage, each battery is 170 amp hours at the 20 hours. So by wiring in series and increasing the voltage, the amp hours remains the same. So this battery bank here is 24 volt at 170 amp hours. Right. Now after you go from your positive to your negative, then your positive to negative, the positive terminal of the third battery will be open for connection, and the negative of the first battery will be open for connection. Now this is where you will connect, say you going straight to your charge controller, or you going to the inverter, or you going to a bus bar. This is where your connections will be made from. Your positive will come out from here and go into the bus bar or the inverter or the charge controller, and your negative will do the same: bus bar, inverter, or charge controller. Or depends on how your system is wired. Sorry. Mine goes to a bus bar, and then it goes over to the inverter has its share, and the charge controllers have their share as well too. Right. So having that covered now, so these 3 are wired in series. 124 volt battery bank at 170 Ah. Then go over to the next 3 and you do the same: positive of the first battery to the negative of the second battery, positive of the second battery to the negative of the third battery, leaving the same positive open for connection and the same negative open for connection. So you have 1 set, 2 sets of 3, 3 sets of 3, 4 sets of 3, 5 sets of 3, 6 sets of 3 wired in series. Is giving you 6 at 170 Ah, all at 24 volts. Now, what you're going to do now, we're going to wire now in parallel. We will come off from the negative of all the strings, going to connect together. So here we see it, the negative of all the strings connecting together. That's 1, 2, 3, 4, 5, and 6. So all 6 negatives from all 6 strings are connected together, and you do the same with the positive. 1, 2, 3, 4, 5, 6. So you have 6 free negatives that are connected together and 6 free positives that are connected together. Now, this is no one 24-volt battery bank. Because I wired 3 batteries in series, making it 6 24-volt battery bank wired in series. And then I wired each battery bank in parallel. So what I did, I increased the voltage to 24 volts with the first wiring. And then I increased the amp hours with the parallel in second wiring. So I have 124 volt at 1020 amp hours, which is 6 by 170. For the connections, just how I did with the first battery, first 3 sets. Then I said the far end, which is the far end positive, will go to your inverter, your charge controller, or your bus bar, or depending on how your system is wired. And negative will do the same. So the same thing you do with this one side battery bank. You go from the opposite end. So my positive is on this end, the far end on the left, and this here now is the far end on the right, which is totally opposite. So my negative is here, and my positive is here. So you can have an even charge and an even draw on your battery bank. Now with this here, my system I'm using, this is number 8 AWG, which is 10mm square. Now I'm using this 10mm square because I have a 500 watt inverter that I'm using. So 500 watts divided by 24 volt. You can see that this number 8 10mm square can handle that quite comfortable. But for those who want to use a higher wattage inverter, it's best not to use this number 8 and probably use either 1/0 or 2/0 welding cable, because 1/0 is good for 315 amps. That's in welding cable, not the regular AWG, American wire gauge. Cause that's what I'm using here now, American wire gauge 10mm square, or number 8 AWG, which much I say is handling quite well. I went up to about 300 and odd watts just to give it a test, and I did that about for 4 or 5 hours, and this cable never even got warm, because this is capable of handling up to 60 amps with this number 10, with this number 8 AWG 10mm square cable. So that's it. So just remember, if you want to use a higher wattage inverter for your household needs, it's best to get a higher amperage cable, so it can handle the draw and the feed, which is the draw from the inverter and the feed from the solar panels through the charge controllers. So you can be safe. You want to keep solar safe across the world. Right, so that's it. I hope that you found this video helpful, and looking forward to producing some more videos. Thanks for watching. Stay safe.